Venus is often called Earth's evil twin. The thing is, this world once started off quite similar to our home planet. But later, something went wrong. These days, the two planets are relatively close and similar in size. But Venus's atmosphere is very different from that on our planet, all thanks to a runaway greenhouse effect that has been going on for a long time. The surface of Venus can get even hotter than the surface of Mercury, 864 degrees F. And the surface pressure feels as if you're more than half a mile underwater. The thick atmosphere presents its own challenges. Its clouds consist of sulfuric acid, which is used in lead-acid batteries, as well as industrial cleaners. And if you decided to land on the planet, you'd have to survive atmospheric entry, with friction heating you up to 20,000 degrees F. Still, people have always wanted to explore this inhospitable world, and we can't but talk about the Venera program. During the 1970s and 1980s, several spacecraft studied Venus from orbit and from its hostile surface for an hour or so at a time. The 10 successful Venera landers provided us with most of the data we have today about the surface of this mysterious planet, including surface composition, direct measurements of atmospheric conditions, and sets of unique images. At the same time, astronomers got their hands on these treasures only after a series of annoying failures. They started with Venera 1, launched in February 1961. Each consequent spacecraft was somehow improved and upgraded. But it still wasn't until the fifth group of Venus-bound space probes launched in 1967 that one of them, Venera 4, reached its target and sent data from Venus. Before that, Venera 2 and 3, launched in November 1965, were supposed to land on Venus, but both of them failed in transit. 11-foot-tall Venera 4 was a hefty thing. Its bottom lander was a bunch of instruments and a battery wrapped up in a pressure shell equipped with a parachute. This probe reached Venus in October 1967 and successfully launched the lander. The mother spaceship sent the probe flying over the planet, and it entered Venus's atmosphere. Temperatures were reaching 20,000 degrees F, and the entry force was as great as 450 G. It didn't prevent the onboard instruments from analyzing the atmosphere and sending back data. The first recorded temperature was 102 degrees F, and atmospheric pressure was similar to that on Earth. But the deeper the probe went, the higher the numbers became. 10 atmospheres, 20. They kept going up much higher than engineers had anticipated. 93 minutes into the mission, when the probe was still more than 16 miles above the surface of the planet, Venera 4 cracked open near its top and crashed. At the crash point, the measurements showed 22 atmospheres and 530 degrees F. Scientists realized that they needed a bigger spaceship. After some intense engineering, Venera 5 and Venera 6 saw the light of the day. Engineers did everything they could to make the landing probe stronger, but they were pressed for time. That's why Venera 5 and 6 were not fully prepared when they went on a mission. That's why Venera 5 transmitted data for a mere 53 minutes before succumbing to temperatures of 600 degrees F and pressures of 27 atmospheres. And Venera 6 lasted for 51 minutes. In any case now, the leaders of the project knew what it would take. 840 degrees F, 100 atmospheres, corrosive acids. They seemed to be prepared. They found new materials to build the probe. They got a hotter and stronger test chamber for the trials. They modified the parachute to make the lander fall faster so that the probe could spend as much time on the surface as possible. The lander was also designed in the shape of an egg and made of titanium, so its surface was smooth and had just a few ports, welds, and substructures. The insides were lined with a shock absorber and insulation layer. The chamber was also to pre-chill to freezing temperatures before entry. And Venera 7 was finally a success. It reached the planet in December 1970, separated from the mothership, and went down into the atmosphere. The probe transmitted data for 35 minutes, and things seemed smooth. But then, its chute melted, and the probe dropped like a rock, hitting the ground at 35 miles per hour and bouncing. Then, a second after the landing, the signal was abruptly cut, It looked like the probe crashed to bits. Shockingly, a few months later, while looking through all the data they managed to get, engineers rediscovered the signal. It was super weak and lost amidst the noise. Apparently, when Venera 7 bounced, it misaligned the antenna. The probe rested on its side, which weakened the signal to 1 or 3% of its initial strength. The probe kept transmitting data for 23 minutes. After that, the temperatures got too high and melted its shell. Venera 8, launched in 1972, had a similar design and experienced a similar fate. Venera 9 and 10 were a new generation of probes. They could send back black and white photos. It was actually the probe's main goal, to send the first ever photographic panorama from another planet. Venera 9 and 10 were 5 times heavier than their predecessors and weighed 5 tons at launch. The lander was 6.5 feet tall. It was basically a hermetically sealed titanium sphere that was supposed to hold the instruments. It was bolted with gold wire seals. Inside, there were shelves of beryllium and electric fans, whose main goal was to disperse heat to prevent instrument failure. On the bottom of the lander, there was a shock-absorbing ring. And at the top, there was a titanium ring that looked like a hat. It served as an aero brake. The parachute was supposed to detach at 30 miles above the surface, and the aero brake had to do the rest. In October 1975, Venera 9 and 10 arrived at Venus and landed as planned. Venera 9 was the first to land. It touched down on a slight slope, a volcanic crater or a hill, and kicked quite a bit of dust while landing. One of its 2 cameras succeeded in photographing and transmitting data, and soon scientists saw the first ever pictures of the surface of Venus. It was mostly sharp rocks, soil, and a distant horizon. The sun was slightly obscured by clouds that day. A gentle breeze was blowing. Overall, it was a pleasant morning. If you didn't pay attention to crushing pressure, almost completely waterless atmosphere, insanely high temperatures, and corrosive acids. Venera 10 landed in the same way a few days later, but the terrain it landed on was much more boring. Just a rolling plain with hardened pieces of magma. Both probes transmitted for 40 to 60 minutes until their orbiters went out of range. When it happened, the temperatures inside the probes were reaching 140 degrees F. The orbiters later burned up in the atmosphere after completing their mission. Venera 11 and 12 could have been a success, but a mysterious electric anomaly messed up with their cameras, so their trip was quickly forgotten. And Venera 13 and 14 entered the picture. They had improved scientific instruments and cameras that could take color images, and new heat-resistant technologies were used during the creation of these probes. Venera 13 arrived first and landed as planned. It took 2 photos, one black and white and the other in color. In the photos, one could see a surface of pebbled, loose soil and outcroppings of bedrock. It all looked pretty similar to the surface of the ocean. In the distance, there were rolling plateaus and an orange sky. The images taken later by Venera 14 showed a more weathered plain with less loose soil and fine-grained rocks. The 2 probes also sent back what they heard. It mostly sounded like a gently blowing wind with hints of distant rumbling. Could be Venus quakes. Venera 13 and 14 were the last landers to touch the surface of the planet. Venera 15 and 16 just flew around Venus, mapping its topography from orbit.
Venus has more volcanoes than any other planet in the solar system, more than 1,600. And a day on Venus, measured by how long it takes to rotate once on its axis, takes longer than the time it takes to complete a full orbit of the Sun. Wow! And that's just Monday. An extreme greenhouse effect warms the planet's surface up to 870 degrees Fahrenheit, hot enough to melt lead. Winds there reach the speed of 450 miles per hour in the middle cloud layer, faster than the speediest tornadoes on our planet. The pressure on Venus's surface is 90 times higher than that at sea level on Earth. What a great place for a vacation, huh? And recently, this incredible place has become even more intriguing. In the toxic Venusian atmosphere, there's something that might mean the existence of life. Unfortunately, scientists haven't had a chance to collect any microbe specimens or snap any pictures of life there. But they've discovered a chemical called phosphine, and it's a big deal.
If it's not some previously unknown chemistry that produces the gas, then there must be a kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any normal life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen. For example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially.
The weirdest thing is that phosphine isn't supposed to be in Venus's atmosphere at all. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, the famous gas giants, but on Venus? Totally unexpected. There's no way phosphine can be produced naturally on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere. But it's not nearly enough to explain what the astronomers have observed. It would only make 1/10,000th of the phosphine the telescope saw.
But let's start from the very beginning. In 2017, a group of scientists led by Jane Greaves from Cardiff University started to use the James Clerk Maxwell Radio Telescope in Hawaii. That's a mouthful. The main idea was to search for phosphine gas. It would be a sign of life on Venus. When the data came back and the researchers analyzed it, they were shocked. The phosphine signal was powerful. The team checked the results several times. They wanted to make sure no other substance mimicked the presence of phosphine gas.
So now, does it mean there's life on Venus? Not necessarily. If this gas is created by some mysterious organisms, it's a big question how they survive on Venus. On our planet, some microbes can thrive in the environments with the acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid. And even though they have a rather pleasant temperature of 86 degrees Fahrenheit, these clouds contain more than 90% of sulfuric acid. DNA, amino acids, proteins, life components on Earth would be dissolved there in the blink of an eye. The surface of the planet is too hot for any kind of complex molecules to make up life. The Venusian atmosphere is almost 50 times as dry as the driest place on our home planet. There's a theory that microbes might hide in scarce water droplets floating in the atmosphere, but it hasn't been proved yet.
Right now, the research team's waiting for more telescope time. They're going to look for other gases associated with life. But even if they find more evidence, life forms on Venus will be made up of building blocks absolutely different than those on Earth. Or they might be protected by a sulfuric acid-resistant shell. It can be made of such substances as sulfur, wax, graphite, or something else we can't imagine.
Of course, some experts question the idea of life on Venus. They think the gas might be produced during some geologic or atmospheric processes happening on the planet. But the supporters of both theories agree on one thing: the discovery is extraordinary. Interestingly, astronomers have always tried to find signs of life on giant planets' icy moons, or even closer, on Mars. But they've never seriously considered Venus. If additional telescope observations and future space missions confirm that phosphine is produced by living organisms, we can be in for a bunch of exciting surprises. Then people would know of a planet with an alien biosphere, well, alien to us, and this planet would be just next door to Earth. Now, speaking of visiting Venus, though, would it be possible for people to land on this planet? After all, robots are already tooling around the red planet surface. On the pro side, Venus is closer to Earth than Mars, but it also has much harsher conditions. The planet is hotter than Mercury, even though Venus is almost double the distance from the Sun. The temperatures are higher than the melting point of many metals, and some of them, like lead or bismuth, can fall as snow on the highest mountain peaks. If you set foot on the planet, you'll find nothing but barren rock. Giant basaltic plains are littered with volcanoes and mountains. In some places, the surface melts because of the heat underneath. After it releases some of it, the rock solidifies again.
If people ever go to this planet, they will most likely build floating cities in the clouds of Venus's atmosphere. At about 31 miles above the surface, the conditions, like the pressure and gravity, are similar to those on Earth. The temperature is rather manageable too, at around 167 degrees Fahrenheit. Think Death Valley, California on a really hot day. The atmospheric pressure is half of what we have at sea level on our planet. If you went outside, you'd be fine without a pressure suit. The pressure you'd feel would be the same as at the top of Mount Kilimanjaro. Plus, this colony would be protected from the sun's radiation better than one on Mars.
If the atmosphere was the mission's final destination, landing a spacecraft, or rather making it hover in the air, would look very different. The idea is to use an airship in the upper atmosphere for long periods of time. The airship, wrapped in an aeroshell, would enter the planet's atmosphere at a speed of 24,000 feet per second. In the next 7 minutes, its speed would drop to around 1,500 feet per second. After that, a huge parachute would open. It would slow the spacecraft down even more, and then things would get a bit hectic. The aeroshell, not needed anymore, would drop away. The airship would then inflate itself, all the while hurtling through the atmosphere toward the planet's surface. Its speed would be at least 330 feet per second. It would get larger and larger, and its drag and lift would increase. Soon, the parachute wouldn't be needed anymore. The crew would get rid of it, and the airship would fill with air completely. If everything went as planned, it would stop 30 miles above Venus's surface. After that, the airship would travel around the planet. It would be moved by the wind, which can reach a speed of 220 miles per hour at the top of the cloud layer. If you decided to move closer to the surface, though, you'd have to be extremely careful. The wind in the middle layer can get twice faster. The airship could be filled with a breathable mixture of hydrogen and oxygen gases. Such a combination would be less dense than the Venusian atmosphere. It would provide the needed buoyancy, to stay up there. Venus is famous for its super dense clouds. These clouds make the planet shine bright enough to be seen from Earth. Venus reflects more than 75% of the light that comes from the sun. This reflective cloud layer exists thanks to a haze of sulfuric acid droplets in the atmosphere, and they gather exactly at the height where the airship would float. Luckily, people already have a method to overcome the problem of acidity. A few materials, for example Teflon and some types of plastic, have an amazing acidic resistance. They could protect the outsides of the ship. So, let's say you needed to work on a platform outside. Then you'd be able to do it, wearing only a chemical hazard suit and carrying necessary oxygen supply. Ooh, sounds like fun, huh? Yeah, me neither.
In our solar system, most planets spin counterclockwise, but not Venus. This rebel planet decided to spin clockwise, and scientists are still trying to figure out why. By the way, why do planets rotate in general? What defines the speed of their rotation? Does the sun rotate? Buckle up and let's try to answer these questions. Venus is the second planet from the sun and the hottest planet in our solar system. Did you know that Venus is sometimes called Earth's twin? That's because it's similar in size and composition to our own planet. But that's where the similarities end, because Venus is a pretty crazy place, to say the least. For example, the weather. On Venus, it's always hot and cloudy. And when I say hot, I mean it like it's over 800 degrees Fahrenheit there. And those clouds? They're not made of water like the ones on Earth. Instead, they're made of sulfuric acid. So yeah, you wouldn't want to go outside without a really good sunscreen on Venus. If you look at the photos taken from its surface, you can see these toxic yellow clouds and cracked, desolate landscapes. And the spacecraft that captured this turned off almost immediately after sending these photos. Poor fella. But the surface of Venus isn't just some solid, dark, flat land. In fact, Venus has mountains that are taller than Mount Everest. These mountains aren't made of rock like the ones on Earth, though. Instead, they're made of a kind of volcanic material that's denser. Venus is a pretty creepy place that holds many mysteries. One of them has been puzzling scientists for years, and this is the planet's rotation. Most planets in our solar system rotate counterclockwise, but Venus isn't like the other girls. It rotates clockwise, and that's not all. It also rotates around the sun faster than it rotates around itself. In other words, a year on this planet passes faster than a day. It's almost like Venus made being quirky its life mission. But why is that? Well, scientists have a few theories. The most popular theory says that Venus was actually spinning counterclockwise like the other planets, but then something happened to flip it around. And what could that something be, you ask? A planet-sized object. Yep, astronomers believe that something huge once collided with Venus, causing it to spin in the opposite direction. You can imagine this like a cosmic billiard shot, with this mysterious huge object being the cue ball and Venus being the target ball. But we can't actually say that Venus is spinning the wrong way. There's no such thing as a wrong direction of spin in the universe. This is actually called the retrograde rotation. This is when a planet rotates in the opposite direction to its orbit around the sun. Venus, for example, has a retrograde rotation, which means that the sun rises in the west and sets in the east on that planet. So now when the horoscope says something like Mercury in retrograde, you'll know what it means. Oh, but Venus isn't the only weird one in our solar system. There are definitely some wacky ways that planets can rotate. For example, most planets in our solar system spin around an imaginary line called an axis. This axis is usually straight up and down in relation to the planet's orbit around the sun. However, some planets like Uranus have a tilted axis, which means it's almost on its side in relation to its orbit. This tilt causes the planet's poles to be nearly in the same place as its orbit. The result? As the planet orbits the sun, different parts of it receive different amounts of sunlight, causing extreme seasonal variations. For example, one pole might experience continuous sunlight, while the other is in complete darkness for a long time. Uranus is the only planet in our solar system that rotates on its side. Scientists think that it could repeat Venus's history. Once upon a time, a large impact knocked Uranus off its original axis of rotation, causing it to tilt at an angle of 98 degrees. We should be grateful for Jupiter. Its crazy gravity pulls all the asteroids and protects us from such collisions. All this is somewhat similar to tidally locked planets. Imagine going on a date with a planet, but instead of being charming and mysterious like you'd hoped, it's just staring at you with the same face all night long. That's basically what it's like to hang out with a tidally locked planet. Tidally locked planets are planets that rotate around their axis at the same rate that they orbit their star. This means that the same side of the planet always faces the star, while the other side is in permanent darkness. Being tidally locked can have some weird effects on the planet's climate and weather. The side facing the star can become extremely hot, while the other side can be incredibly cold. The atmosphere on the planet can also get pretty wild, with strong winds blowing from the hot side to the cold side. And it doesn't have to be planets only. Our moon also works this way. Did you know that we always see only one side of the moon? That's because it's tidally locked to the Earth. We can also take the dwarf planet Pluto as an example. It has a strange rotational relationship with its largest moon, Charon. They're tidally locked, which means that they always face each other with the same side. As a result, Pluto and Charon appear to waltz around a common center of gravity, creating a unique dance in space. But the oddities of our solar system don't end there. There are also planets with super fast rotations. While most planets rotate at a fairly sedate pace, some of them are sonic levels fast. Jupiter, for example, rotates once every 9 hours and 56 minutes, which means that it has a day that's less than 10 hours long. That's fast enough to cause the planet to bulge out at its equator. And also, this rapid rotation creates strong bands of winds that can reach speeds of up to 400 miles per hour. And if all this still seems logical and kinda makes sense, then how about chaotic rotations? Yep, some planets have a rotation that's so irregular and unpredictable that it's known as chaotic rotation. This is often caused by the gravitational influence of nearby moons or other planets. And it's mostly the case with moons and small objects like that. In our solar system, some moons of Pluto, Saturn, and Neptune have chaotic rotation. By the way, the Sun rotates too, just like the planets. However, its rotation is not uniform. The equator rotates faster than the poles. Pretty weird, isn't it? This phenomenon creates a magnetic field that's responsible for phenomena like sunspots and solar flares. But all this raises an interesting topic. Why do planets rotate in the first place? This may sound like a silly question, but can you answer it? The answer might be trickier than you imagine. It all started around 4.5 billion years ago with the formation of our solar system. When it formed, it started as a large cloud of gas and dust. As the cloud began to contract due to its own gravity, it began to spin faster and faster, like a spinning top. This spinning motion caused the cloud to flatten into a disc-like shape. As the cloud continued to contract, the center became denser and hotter, eventually forming the Sun. Meanwhile, the material in the disk began to clump together and form planets. But because the disk was already spinning, this spinning motion was inherited by the planets as they formed. In other words, the planets rotate by inertia. They inherited the spinning motion of the cloud of gas and dust from which they formed. This is known as the conservation of angular momentum. This is the same principle that causes ice skaters to spin faster when they bring their arms in. And that's a wrap on the wacky world of planet rotations. From the lightning-fast spin of Jupiter to the bizarre backwards rotation of Venus, it's clear that our solar system is full of surprises. But thanks to the laws of physics and the gravitational pull of the Sun, these planets continue to spin on, keeping time with the steady beat of the cosmos. Stay tuned.
Earth. The third rock from the Sun. The blue planet. You get it. Its atmosphere is made up of around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide. A nice balance for any living creatures to breathe. The weather here is also perfect for life to exist, unlike places like Saturn, Mercury, or any other celestial object in our solar system. We have the troposphere to thank for that. It's the densest part of the atmosphere on our planet and is 5 to 9 miles wide. It's the layer of the atmosphere that always affects our weather and secures the right conditions for life to exist and to have bodies of water. Earth is just sitting in its orbital path, minding its own business, revolving around the Sun until, BAM! Venus and Mars swoop in and spoil the fun. No one wants to leave poor Earth alone. These two relatively large celestial objects moving toward Earth will have dire consequences for our planet, starting with changes in its orbiting trajectory path. The planet's orbits in the solar system have to maintain the right balance so that nothing goes haywire. Of course, if any large object approaches Earth, it would throw our orbiting path off course. The planets will revolve around each other, which will cause plenty of natural disasters on our lands. This will also affect our rotation timing, potentially slowing it down. Days will not flow but drag by. Animals that rely on daytime will need to readjust their biological clocks. Nocturnal animals will also need to figure out how to cope with the long nights. Humans have adjusted pretty well to the 24 hours a day timing. Time itself is just a human construct to measure things. We'll have a tough time sleeping and adjusting to the stretched day. Marine animals rely on the natural current flow to migrate around the oceans. With Mars and Venus crashing the party, it looks like they will also need to find new paths. Birds migrating to other lands throughout the year will also be confused and not know what to do. In general, the Earth's temperature will rise, and massive heat waves and permanent climate changes will occur. This brings us to our next issue, the heat. The radical temperature rise will turn everything into a barren desert. It'll be summer all year long, especially if Venus is in the picture. Most of the planet will dry up and won't be suitable for growing crops. Venus is hot, I mean really hot. Even though it's not the closest planet to the Sun, it's still the hottest. The temperatures on Venus are close to 900 degrees Fahrenheit, which will melt you like an ice cube. The lands on Venus are generally flat, probably due to the temperatures. It's mainly hot because its atmosphere is thick and traps the hazardous gases inside. If Venus inches its way towards us, it'll invite those gases to our atmosphere and compromise it. Mars, or the red planet as we know it, is very cold. That might stay the same if it starts rotating around us. It's also home to the largest dormant volcano in our solar system, which makes Mount Everest look like a tiny bush compared to a tree. With so much instability, it might just wake up one day and spew out molten lava. Mars has a very thin atmosphere, which makes the planet chilly. Its gravity is quite similar to ours. It's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and sunset. The three planets orbiting each other will eventually collide. It's just a matter of time. And the Moon, just hanging out like a fly on the wall, will be so insignificant that something will eventually throw it off course and another planet will capture it to its orbit. Or, in the most dire case, it will collide with one of the two intruding planets. Earth will experience extreme tidal waves like nothing before. The two new planets revolving around Earth will cause a major imbalance, making our gravity shift out of control. Each tidal wave will be bigger than the previous one and will cover the dry land. Plenty of little scattered islands in the oceans will be completely submerged. Coastal cities and towns will also be home to fish. Flat countries in general will need boats to get around. Dams and dikes won't be enough to stop the water from coming in. Everyone needs to move towards higher ground to escape the floods. With the climate getting hotter, the polar caps will melt like ice cream on a sweltering summer day and add to the water level rising. Within a few months, the whole Arctic will be nothing but liquid. But wait, there's more! The crust will wear out due to the instability of the Earth's surface and fluctuating gravity. The Earth's crust is mainly made up of oxygen, which means we're basically walking on air. We might experience more earthquakes than before, and dormant volcanoes will wake up from their deep slumber. The skies will be covered in ash, making flights impossible. No one can travel by sea or by air. Importing and exporting will become history. The overall climate will get hotter, just like in Venus. The three planets orbiting each other and their huge mass might even unintentionally welcome other planets and celestial bodies to join the party. So, what if Jupiter decided to turn up? Now, Jupiter is the largest planet in our solar system. To give you an idea, the Earth would be just the size of a grape if Jupiter were the size of a basketball. It also has the largest storm we can perceive. That's known as the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. Now, by the time you're done watching this video, you can expect the storm to still be going at it. Since the planet is huge, gravity must be quite strong here. It also has many moons, some of them of our little Earth. There will be no room for any proper space among the planets. Jupiter's moons will be thrown off course and latch onto other planets around. Some of the moons might collide with each other, causing massive debris to be displaced all over the place. The gravity of the planetary party will attract comets to enter the atmosphere, potentially crashing down on us. Oxygen levels will deplete, so the Earth's crust crumbling will continue. It'll rip open the ozone layer, causing heavy strokes of ultraviolet waves to enter our atmosphere. We won't be able to step outside for too long without some protective gear and oxygen tanks. Human civilization will change drastically. We'll all live in sheltered containers that will provide clean air and safe and filtered sun rays. The shelters will be sturdy enough to withstand frequent earthquakes. We will grow only enough crops to sustain ourselves until we leave the Earth. Since it'll only be a matter of time before the planets collide, The next step would be to create large rocket ships to fly us out of the Earth. With Mars, Venus, and Jupiter revolving close to us, it won't be easy to do so. All the space debris will be blocking us from exiting the space zone area. The only safe place outside this region will be many millions of miles away, where only single planets exist. They may or may not have the conditions to host life, but humans will have the technology to land just about anywhere with similar gravity and construct the right shelters. Eventually, Mars, Venus, Earth, and Jupiter will collide with each other and break like eggs, like a big space omelet. Don't forget the moon's crashing and breaking in the mix, but we'll already be far, far away by then, hopefully. What would happen if our planet turned into two separate ones, one consisting entirely of land and the other one of water? Could we survive on any of them, and how? Well, you're lucky, because I'm going to answer this question right now. So let's imagine that our Earth has turned into two separate planets sharing one orbit. Let's call these hypothetical planets rock and water. I know, very original. Anyway, let's start with the rock because this one is much easier to imagine. All we should do is ask, what would happen if all the oceans on the Earth suddenly dried up? Now, we know that water is life. It covers 70% of the surface of our planet. There's so much water that even if all the oceans and seas disappeared, some of it would still be left in underground rivers, streams, and so on. But unfortunately, it would not be enough for us to survive. All sea creatures disappear. After some time, all other animals, plants, and of course, people share their fate. Completely dried forests burst into flames sooner or later and burn until there is nothing left but ashes. But hey, it's not that bad. Well, it is bad, but life can still exist in some form. There are some bacteria that make cockroaches jealous. They're able to survive absolutely any conditions. For example, extremophiles have already evolved to live without water. These little guys can survive in an incredibly hot or acidic environment without water or even sunlight. Without them, the rock becomes an empty, lifeless planet. Although, who knows? Maybe someday extremophiles will be able to evolve into some wildly cool forms that can survive literally anywhere. But for now, the rock is just a floating rock, basically. Oh wait, did you imagine a hot desert or some sort of red-hot steppes? Surprise, surprise! This planet is actually extremely cold. You see, without water, there would be no atmosphere. The atmosphere consists of a concentration of various gases, including hydrogen and oxygen. Some H and O, you know where this is going, right? Yep, no water, no atmosphere. And since it is the atmosphere that accumulates all the heat we need, the planet would be very cold without it. The contrast between cold and less cold places also becomes very sharp. You see, water is basically a climate stabilizer. The oceans absorb almost all of the heat of our sun. They distribute it evenly over the Earth to make sure it doesn't get too cold or too hot. So without it, the rock gradually turns into a cold desert. The average temperature on this planet is around minus 100 degrees Fahrenheit. At both poles, the temperature is extremely low, about minus 300 degrees. And even in the warmest places, it doesn't exceed 20 degrees. These warm places are now the former oceans because their dried-up depths are located much closer to the hot core of the planet. Wait, I hope you don't imagine this planet as covered in snow either. We don't have any water at all, remember? It's just a very cold rock. At this point, we're just a bigger and browner version of the moon. The moon is basically a waterless piece of Earth, after all. But hey, what happens to volcanoes? They're basically our last hope to stay warm, aren't they? Unfortunately, volcanic activity is decreasing due to a lack of water. You see, volcanoes and their eruptions happen because of the collisions of two tectonic plates, the oceanic and continental ones. The weight of the water presses on the oceanic plates. They go under the continental plates and form volcanoes. So if there's no water weight, then there's no volcanoes and volcanic activity drops significantly. The rock now is just a planet full of many incredible high mountains. And every time the tectonic plates collide, they form more and more of these mountains and trenches, including some very big ones, like the famous Mariana Trench. I would say, be careful not to fall, but hey, there's no one to fall there. So? Also, there's no weather anymore. No water means no more snow, ice, or rain, or even clouds. The wind would probably be quite strong, though. Well, that's the fate of the planet Rock. Not very bright, so let's just go see how the water planet is doing. Many, many billions of years ago, I wasn't around then, our Earth actually was a planet entirely covered with water. Then, about 1 billion years ago, the sea level dropped, the land appeared. This has changed the atmosphere of our planet forever, and that's how life was born here. But what happens if it returns to its original state? Well, to answer that question, we should first learn more about the ocean planets. So, what does one of these look like? Oh, sorry, I almost forgot. We have no idea. We haven't found any planets of this type because they're incredibly rare. I mean, there is one planet that is low-key and could be called an ocean planet. Yeah, I'm not even going to try and pronounce that. Still, even this one doesn't look the way you probably imagine. The water on it is in a very weird, unique state. Scientists have called this hot ice or superliquid water, and we've never seen anything like this before. In general, though, the actual ocean planets are very hard to find due to many physical reasons. These planets require very specific temperatures, pressures, and so on. But alright, just hypothetically, what would such a planet look like? Well, first of all, of course, it cannot be made entirely of water. I hope you didn't actually think that there could be just some gigantic water blob spinning around a star. It should still be a planet with a core and some kind of foundation. So let's just imagine that all the water on the former Earth has mixed into one giant salty ocean. Wow, that would be a dream come true for the sea creatures, but not for the rest of us. The only animals that could survive in this situation, except fish, are probably the birds that can swim and feed on fish. Now, I think even if the sea level rose significantly, at least a couple of islets could still stay above the water. Such islands would be the former peaks of huge mountains like Mount Everest. So if these birds build their nests there, they can even survive for some time. But what about you and me? Well, we still have a chance. If we had enough time to prepare for the huge flood, we could stay safe either in giant submarines or on giant ships. We can grow food on board and fish from the ocean. But without the Everest Islands, we are unlikely to last long. If something breaks and we have nowhere to dock, we won't be able to fix it. Unfortunately, we no longer have drinking water. Now we can get it only from rain or by filtering seawater. But we have to store it someplace, right? And all these water containers would take up a lot of space and be very heavy. But in general, planet water is not as bad as it might seem. It's quite warm. The average temperature here is about 50 degrees Fahrenheit. And the gap between the lowest and highest temperatures is minimal, from minus 20 degrees at the poles to 70 degrees at the equator. Compared to planet Rock, this ain't bad at all. Planet water would also be slightly larger than the Earth in radius due to the volume of, yes, water. The density of this planet would be, on the contrary, quite low. The gravity could become a bit weaker, too. Now, as for both planets, if we place them in the Earth's orbit, after some time, they would still move away from each other and follow different trajectories. They would have aligned themselves not to collide with each other. On one of them, the year would last 12 months, and on the other one, 10 or 11. And that's about it. A fun fact, all of this can actually happen in the future. First of all, the Earth's crust is gradually becoming thinner. Hey, I like thin crust. On my pizza. On my planet, not so much. So, one day, water can really flood our entire land. On the other hand, in a couple of billion years, when our sun begins to expand and turn into a red giant, all the oceans on our planet will really dry up. Alright, take a deep breath and shake it out. That's enough of this grim fairy tale. It's a waste of time to worry about such things so far off when, today, I can't find my wallet anywhere. I thought I put it over here. So Venus and Earth are so different that a foolish question like, what's longer, a day or a year, that makes absolutely no sense on Earth, totally makes sense on Venus. A day on Venus is indeed longer than a year. If we put it into Earth's perspective, a day on Venus would equal 243 Earth days, while a year would only last 225 days. So it's like your birthday is every day. Venus is often nicknamed Earth's evil twin. Their differences are so stark, you'd think they're from different galaxies altogether. Just to give you an idea of how far apart they are, if the day-to-year ratio wasn't enough, the Earth rises in the west on Venus but sets in the east. These days, one of the very few similarities between these two is their size. But try to imagine a time when Venus and Earth were like peas in a pod, besties since the beginning of the solar system. Venus used to be the life of the party. NASA scientists think Venus might have even hosted a liquid water ocean and surface temperatures that could have welcomed life for up to 2 billion years. But modern-day Venus is a different story. We're talking extreme temperatures and a thick carbon dioxide atmosphere. So, what led to this cosmic makeover? Size, location, and attitude. I mean that the distance from the Sun and internal heat played a huge role in shaping Venus and Earth's destinies. By the way, there used to be 3 siblings that could have hosted life: Venus, Earth, and Mars. Now imagine 3 cupcakes in an oven. Once they were fully baked, they were taken out of the oven. One of them was put in front of an open window in the middle of winter. Another was carefully placed on a table and covered with a nice clean kitchen towel. And the last one was accidentally forgotten and left in the oven. Oops. Mars, Earth, and Venus are like those cupcakes. Mars got too cold and not welcoming. Earth is still nice and warm and well protected from all the unpleasant things, just like the towel protects that lucky cupcake. And Venus got scorching hot and impossible to consume. In terms of development, Earth took the slow and steady route, maintaining its oceans, stable atmosphere, and biodiversity. Venus, on the other hand, cranked up the temperature, evaporated its oceans, and went all in with greenhouse gases. As a result, we have a planet where you'll melt faster than a snowman in July. Mars, on the contrary, will turn you into an ice popsicle within seconds. But chances are, it might have been pretty hospitable at some point. Some scientists believe that Mars used to be covered with flowing rivers and lakes and had no water shortages. Even today, Mars still has an ocean called Oceanus Borealis, or rather, the remains of what once used to be an ocean. It lost nearly all its water over time. Now, the sources of water on Mars include polar ice caps and minerals and rocks. According to estimates, only 1% of all that water evaporated, while 99% is still locked in the red planet. Ice polar caps are pretty simple to understand, as we have the same thing on Earth. But rocks containing water? Simple. There are at least 4 types of hydrous minerals on Mars. There are hydrous clays made of silicon oxygen, and the cool thing about them is that they can even contain magnesium and iron, which are sulfur-based hydrous sulfates. Now, don't you? I know you thought of the smell of rotten eggs. But it's typical of hydrogen sulfur and not just sulfur. These minerals have water incorporated right into their chemical formulas. There's also hydrous silica, which has water locked in its formula too. Scientists have experimented with growing plants using Martian-like conditions and found success with alfalfa. Harvesting alfalfa also helped improve the growth of other crops like turnips and lettuce. While water may be available on the red planet, the air on Mars is mostly carbon dioxide. On the bright side, and the Mars Oxygen In Situ Resource Utilization Experiment, the Mars Oxy can produce oxygen on Mars, which could be crucial for future missions. As for energy sources on Mars, solar, wind, and geothermal energy are a few promising options. Solar power is less effective on Mars due to weaker sunlight and dust storms. But wind power and geothermal energy could serve as reliable alternatives. With these sources in place, humans could potentially sustain life on Mars. But let's get back to comparing our sibling planets. While both Mars and Earth have moons, and Mars even has 2 of them, Venus has 0, just like Mercury. Due to its proximity to the Sun and the star's gravitational pull, Mercury lacks the ability to retain its own moon. The likelihood of any moon orbiting Mercury either colliding with the planet or being drawn into the orbit of the Sun is high. That's all clear and understandable. But the absence of moons around Venus remains an unsolved puzzle for scientists. Despite Venus's scorching hot temperatures, scientists think that even today it might not be as hostile to life as we once thought. A recent MIT study found 19 amino acids surviving in a Venus-like solution for the whole month. Yep, some like it hot. Also, Rocket Lab and the Massachusetts Institute of Technology are teaming up to send an uncrewed spacecraft, Venus Life Finder, on a mission to Venus. This spacecraft will search for signs of life in the Venusian atmosphere using a special instrument called an autofluorescing nephelometer. And no, I didn't make that up. Originally set to launch in 2023, the mission is now pushed back to December 2024 with arrival at Venus in May 2025. The goal of the mission is to discover organic compounds in Venus's atmosphere, which could point to the possibility of habitable conditions in the cloud layer. The spacecraft is designed with a Photon Explorer cruise stage and a compact atmospheric probe equipped with that nephelometer thingy. The small probe will descend through the Venusian atmosphere, collecting data on cloud particles and organic compounds. In 2020, scientists made a big announcement about finding phosphine on Venus, a compound that could be linked to life. While they're still working on confirming this, using information from telescopes or even past missions, there might be evidence hidden in old NASA data received from Venus that could shed more light on the discovery. The potential presence of phosphine on Venus has stirred excitement and caution among scientists. To make sure, they need more data from telescopes or new space missions. If they find this gas, it might mean there is some form of life producing it in the planet's clouds. This discovery would be a huge step toward understanding Venus better. Some experts think that sending probes to Venus to directly detect phosphine would be the most effective way to confirm its presence. An 80s NASA mission may have already detected phosphine, but scientists back then didn't realize it. Now, this data is being reevaluated to uncover any overlooked evidence of the presence of the gas. This could also suggest that the compound has been in Venus's atmosphere for decades, raising questions about its source. But not everyone is convinced of this interpretation, which evokes a debate among scientists about the true nature of the detected gases. Old data from other missions may also hold clues about phosphate on Venus. While new spacecraft are going to explore the planet, it's possible that the key to unlocking this mystery lies in decades-old mission records. In total, there have been 46 space missions to Venus, including some flybys where gravity lent a helping hand. The last time we successfully landed a spacecraft on Venus was way back in June 1985 as part of the Vega 2 mission. So, let's see what Venus Life Finder will discover.
Could it be that the entire universe is nothing more than just an atom? When you look at a diagram of an atom, which is a building block for all matter, you can see that some examples of the universe repeat. Our solar system is a great example of that. There's a giant central star and a couple of smaller planets that circle around it. You can observe the same arrangement outside our galaxy too, with exoplanets orbiting their stars. And you can also witness that principle on a smaller scale. It's the way particles called protons and neutrons move around the center of an atom, which is called the nucleus. So imagine you have a bunch of positive magnets you're trying to stack together. They keep pushing each other away, right? That's what's supposed to be happening with the protons in an atom. They're all positively charged, so they should be repelling each other and flying off in all directions. But atoms do exist, so there must be something holding them together. And that something is called the strong interaction or strong force. The nucleus makes up less than 1/100% of the volume of the whole atom, but it usually takes up over 99.9% of the mass of the atom. Once again, similar to our Sun. Anyway, this strong interaction is like a special type of glue that holds the protons and neutrons together in the nucleus of an atom. In a similar way, gravity prevents us from flying away from the ground into the darkness of space. Now, this glue comes from some really smart particles inside protons and neutrons called quarks. These little guys have a strange kind of charge called color. It's not like the colors we see around us. It works like a code that helps quarks stick together inside their host particles. And this code also seeps out and helps hold protons and neutrons together in the nucleus. In a way, quarks are like little builders that are working together to build atoms that make up everything around us.
The Big Bang was said to be a magnificent moment when we got time and space. It's the story we use to explain the evolution of the universe. In the beginning, there was only a very, very small ball of matter the size of a peach, but with a temperature of more than a quadrillion degrees. Ow, that's hot. And this bang in the name doesn't mean there really was an explosion in space. This peach started spreading around, and space was just appearing everywhere. It gave rise to atoms, molecules, stars, and many celestial bodies that filled the empty space of our cosmos. Basically, all the elements that make us formed within a few minutes at the earliest stages of the universe. Let's say like 100th of a billionth of a trillionth of a trillionth of a second. Oh wait, give me a second to process that. Alright, moving on. The growth was incredible at that stage. The universe spread exponentially and managed to double in size at least 90 times. Like me during the holidays. I love chocolate. After the Big Bang, the universe was a hot and dense soup of particles, too hot for atoms to exist. But 380,000 years later, it cooled down enough for electrons to mix with nuclei and form atoms. This is a process we called recombination, and it's what made the universe transparent. Think of it like turning on a light switch. Suddenly, you can see it all. But just because the universe became transparent didn't mean it was bright. It was a dark period, as there were no stars or galaxies yet, like a big empty canvas waiting for something to be painted on it. It wasn't until much later, as the universe continued to evolve, that stars and other bright objects started to form and light up the darkness. And it went on evolving, all the while filling up with planets, asteroids, galaxies, and other things. Okay, so that's the story we've been told for the past couple of decades, and a pretty good one, I should admit. Scientists have studied it so much. They observed the leftover electromagnetic radiation from the young universe. They measured the presence of the lightest elements, only to realize they all line up with the story of the Big Bang. New theories don't say the Big Bang didn't happen. It's a good picture of the cosmos in its early stages, but it's like an unfinished puzzle with some important parts missing. We can't explain what happened before the Big Bang using our current physics, so we need some new math to explain tricky parts, like the so-called singularity. It's the point of infinite density, remember? From the beginning of the Big Bang. And that's where string theory comes in, like a superpowered toolkit that can handle gravity and all other forces combined. Now, one of the ideas that string theory has given us is the ekpyrotic universe. Imagine a big fire that sparks off another fire, and that fire sparks off another fire, and so on. Well, in this scenario, the Big Bang wasn't the beginning of everything. It was just one part of a bigger process. It's the idea of the cyclic universe, a never-ending roller coaster ride with big bangs as beginnings and big crunches as ends, happening over and over again, potentially forever. It's like the universe is constantly hitting the reset button and does it in a really fun way. We could look at this singularity, according to some theories, as a single particle in a much larger system, much like an atom is made up of subatomic particles. And considering all that, the idea says every nucleus of an atom could have a universe inside of it. So our entire universe is just a tiny part of an atom in a much larger universe made of atoms with more cosmoses, with more atoms and more cosmoses. So twisting. The early versions of the idea of the cyclic universe still had one big issue. They didn't match up with our observations of the cosmic microwave background, which is a fossil light that shows how the universe looked when it was only 380,000 years old. So, in March 2020, two physicists from Canada published a study that revealed the math behind the cyclic universe that we missed earlier. If we focus on the moment when the universe shrinks to an incredibly small point and then bounces back to a Big Bang state, we might be able to match up with our observations after all. It's just that we need to wait for more new experiments to fully test the idea. The Grand Unified Epoch, that's what we call the time when the universe was still young. At that time, matter and antimatter, which are like mirror images of each other, existed in roughly equal amounts. But since they are opposing forces, when they come into contact with each other, they destroy each other in a powerful explosion, like fireworks. This means that even though matter and antimatter were constantly created and destroyed, somehow there was always a little more matter than antimatter, which is good because otherwise we wouldn't have anything left. As time went on, particles started to stick together and form more complex things, like atoms and molecules. And eventually, stars formed and created even heavier elements. But someday, a long time from now, all those stars will burn out. When the last star slowly cools and fades away, the universe will turn into a dark void without life, light, or anything we know and assume there is. At some point, voracious black holes will eat all matter in space. Eventually, even those black holes will evaporate away into the tiniest amount of light. Our cosmos will continue to expand. The light will become spread out and unable to interact with anything. So, all activity in the universe will stop. Space will become a vast, empty void with no stars, planets, or anything else, and will end there. Or just begin. And maybe that's where we'll meet again. Our solar system is full of mysterious objects that come from, well, everywhere. In October 2017, researchers in Hawaii spotted a mysterious thing that they dubbed a Oumuamua. This means a visitor from a faraway land in Hawaiian, or that's a really big cow. It followed an escape orbit. It literally escaped from its planet's gravitational pull, like throwing a ball into space, never to return. This meant that this weird thing arrived from somewhere outside of our solar system. There were tons of theories about what it was, from a simple asteroid to an extraterrestrial spacecraft. Scientists even thought it was a chunk of nitrogen ice from a Pluto-like planet. Its strange shape only added to the mystery. The big changes in the light curves showed that this thing could be either elongated like a tube or more flat like a pancake. This thing was unlike anything we've seen before. Oumuamua didn't behave exactly like a comet or an asteroid. Comets are icy and form bright tails when they pass near the sun, while asteroids are basically just rocks and don't form tails. Oumuamua has no tail and doesn't release gas, like me. But it's not your average rock either. Its surface is very shiny, almost like polished metal. When it passed by the sun, it sped up, like it had a rocket on it. And it wasn't the sun's gravity that gave Oumuamua the sudden boost. Scientists aren't sure what caused it. So, what in the world was that thing? After years of study, scientists now think that Oumuamua is probably a comet with frozen hydrogen on its surface. This hydrogen reacted with sunlight, speeding up the comet and changing its path. Oumuamua likely got all that hydrogen from being exposed to tons of cosmic rays for a long time. It got some nice red tint from them as well. Oumuamua was a visitor from a young, chaotic solar system where collisions and migrations happen all the time. Such systems often toss many small objects around. It might have been pushed out by a planet like Jupiter, whose gravity is so insanely strong that it can fling huge things into outer space. The same thing often happens with comets here. Oumuamua already left our solar system, although similar objects visit us sometimes, about once per year. To learn more about these mysterious guests, astronomers plan to send a probe to chase Oumuamua. We'll use Earth's and Jupiter's orbits to slingshot it fast enough to catch up with the comet. But some of the unexpected visitors stayed a bit longer. In October 2019, NASA's Hubble Space Telescope took a picture of a bluish comet trailing dust and gas. It was already in the solar system at the time, around 260 million miles away from Earth, somewhere between Mars and Jupiter. We saw the glowing dust surrounding it, but we couldn't yet see its nucleus, since it's way too small. Well, small is relative here. The thing is about 3,200 feet across, which is like the length of 9 football fields. In March 2020, Hubble images showed that a small fragment of the comet broke away from the nucleus. That means that the comet is very active, unlike Oumuamua. As we observed it further, we found that the nucleus is a loose mix of ice and dust particles. Its surface is also very similar to others, with rough areas and smooth blankets of icy, dusty debris. The comet was discovered by an amateur astronomer, Gennady Borisov, so it got the name Comet 2I Borisov. Congratulations! Scientists quickly confirmed it came to us from outside our solar system. And this thing sure was an enthusiastic tourist. It traveled at a breakneck speed of about 110,000 miles per hour. That's fast enough to circle the Earth 4 times in just 1 hour. This visit was fascinating for several reasons. Most comets in our solar system come from the Kuiper Belt or the Oort cloud. The Kuiper Belt is a region of space beyond the orbit of Neptune. It's like a big, distant ring around the Sun, filled with many small, icy objects. All of them are ancient leftover pieces from the time when our solar system was still very young. The Oort cloud is much farther. It's like a giant bubble around the solar system, also filled with super old icy objects. Most long-period comets come from there. But where did the comet 2I Borisov come from? We still don't know for sure. Scientists say that it likely formed in another star system, which could be either younger or older than our solar system. Would be weird if there was a third option, NASA. Anyway, it might have been kicked out from its home system, just like Oumuamua. Although Comet 2I Borisov is too small to hold on to its own atmosphere, it developed a coma when it approached the Sun. Now, coma is a funny name for that beautiful glowing cloud of gas and dust that surrounds the comet's nucleus. It forms when the Sun's heat causes the comet's ice to vaporize, releasing dust and gas into space. This one was friendlier than Oumuamua and gave us some more time to study it. As a result, we learned more about its cool, unique traits. For example, it had never interacted with another star. But, unfortunately, Borisov had to leave too. Now it's on a path that will take it back into interstellar space. However, there are many more visitors to come, and you might have heard of this one. The Great Comet of 1996. That's what we call the comet Hyakutake. It was also named after the astronomer who discovered it, Yuji Hyakutake. In a beautiful coincidence, it was discovered on New Year's Eve. On March 25, 1996, this thing passed by incredibly close to Earth, only about 0.1 astronomical units away, a bit farther than the Moon. It passed over the North Pole. This made it one of the closest comet encounters in 200 years. It was visible worldwide, and it looked very bright and beautiful in the sky, stretching out widely. And it didn't stay for one night only. It got more and more visible during March, becoming one of the brightest objects in the night sky by the end of the month. The comet only fully faded by the end of May. It's a long-period comet, which means it takes hundreds of years to orbit the Sun. The last time it visited was about 17,000 years ago, and now its orbital period increased to 70,000 years. But don't be upset, there are other comets that will brighten our days and nights. Besides, some space objects prefer to stay around for longer. Now, there's this asteroid with a multisyllabic name that, to pronounce, is above my pay grade. This name in Hawaiian means the mischievous one of Jupiter. Luckily, scientists had mercy on us and dubbed it BZ. Hey, speaking for all the other narrators, thank you. It's a small asteroid, only about 1.8 miles in diameter. You can guess from the name that it shares an orbit with Jupiter. But there's a cool catch. The asteroid moves in the opposite direction, which is known as a retrograde orbit. The unusual asteroid was discovered on November 2014. It orbits the Sun for about 11 years and 8 months, sometimes passing inside and outside of Jupiter's orbit. It's been this way for at least 1 million years, and it will remain so for about 1 million more. But why does it move so unusually? BZ might actually be an interstellar immigrant. Perhaps it passed by our solar system about 4.5 billion years ago, around the time when the Sun was just forming. Then it got captured by gravity, but saved its opposite orbit. Or maybe it came from the Oort cloud. Then it could get its weird orbit from the mysterious planet 9, a hypothetical planet that's believed to exist in our solar system far beyond Jupiter. In any case, this asteroid gives us more insight into the history of the solar system and how organic materials can travel to us from outer space. Now, at any given time, there are thousands of objects in our solar system that come from outer space. They stay here for different lengths of time, but sometimes we get lucky, and they end up teaching us a lot about interstellar space.